You ever feel like you're just fighting with the Linux command line? Like you're speaking one language and it's speaking another? Well, today, we're going to crack that code. We are going to demystify the shell, learn its secret language, and hopefully turn some of that frustration into real fluency.
I mean, you've been there, right? You type a command that looks perfectly fine, it makes perfect sense to you, but then it just fails. Or even worse, it does something totally unexpected. It happens to everyone. And the reason, it turns out, is actually simpler than you might think.
See, the shell isn't just a simple command executor. It's a full-on programming language interpreter with its own grammar, its own rules, its own syntax. So, for this explainer, we're not just learning commands. We're going to learn how to speak its language. Let's dive in.
So here's our game plan. We'll start with the absolute basics, the grammar of the shell's language. Then we'll see how to store information using variables. After that, we'll dig into the different types of commands, create some really useful shortcuts, and we'll finish with a debugging superpower that will totally change how you see the command line. Seriously.
Okay, first up, the fundamentals. Before the shell even thinks about running a command, it does this crucial thing called expansion. It basically scans the line for special characters and variables and interprets them. Getting a handle on this one concept is the key to avoiding like 90% of common errors.
Let's look at a classic example. You type echo, then hello, then you mash the spacebar a few times, and then world. You'd expect to see all those spaces in the output, wouldn't you? But, watch what actually happens.
And poof, they're just gone. The shell saw all those extra spaces and just collapsed them into one single space before the echo command ever saw the text. This is called word splitting. So, how do we tell the shell, hey, back off, leave my text alone? Well, the answer is quoting.
And this is a really crucial distinction. Just think of single quotes like a block of solid steel. Whatever you put inside is preserved exactly as you typed it. No interpretation, no exceptions. Double quotes, on the other hand, are a little different. They're more like a protective bubble. They'll preserve all your spaces, but they still let the shell peek inside and expand things like variables that start with a $sign.
All right, so now that we know how to control our text, let's figure out how to store it. Variables are basically the shell's memory. They're absolutely essential if you want to do any kind of scripting or automation.
Just think of variables as little labeled boxes for your data. Some of these boxes are set up for you by the system, like $shell, which tells you which shell program you're using. These system variables are almost always in all caps. And then you have the ones you create yourself, which, by convention, are usually lowercase. Now here's a key point that trips a lot of people up. The difference between setting a variable and using it. To set it, you just type myvar equals 42. Simple. But to get the value out of that box, you absolutely have to use the $sign. Echo $myvar means, hey, show me what's inside the myvar box. But echo myvar just prints the literal word myvar.
And this brings us to the most important best practice I can give you. The golden rule, always quote your variables. If your variable happens to contain spaces and you don't quote it, the shell will split it into separate words and your command will break in weird ways. Just using echo $myvar instead of echo $myvar is a simple habit that will save you from so many headaches down the line. Trust me.
Okay, so we've covered the nouns, our variables, and the grammar, our quoting. Now let's talk about the verbs of the shell, the commands themselves. Because, as it turns out, not all commands are created equal. The shell has a bunch of commands that are literally baked right into its own code. These are called built-ins. A perfect example is cd for changing directories. Then you have external commands. These are completely separate programs on your computer that the shell just finds and runs for you, like ls to list files or grep to search for text.
So how can you tell which is which? Easy. There's a command for that. It's called type. If you run type cd, the shell will tell you something like cd is a shell built-in. But if you run type ls, it'll show you the actual path to the program, like /usr/bin/ls. It's a fantastic little diagnostic tool for figuring out what's really going on under the hood.
All right, let's talk about a major productivity booster. If you find yourself typing the same long, annoying command over and over again, the shell has a fantastic way to create your own personal shortcuts. They're called aliases.
And the process is super simple. First, you create it. A classic one is alias l equals ls minus l, which turns ll into a shortcut for a long directory listing.
Then you just use your new command like any other. If you ever forget what aliases you've set, just type alias by itself to see a full list. And finally, if you want to get rid of one, just use unalias LL. Easy as that.
And now we've arrived at my absolute favorite part of this whole thing. This is the one trick that, once you learn it, it's going to feel like you've been given a pair of X-ray glasses for the command line. I'm not kidding.
I mean, this is the million-dollar question, right? After all the variable expansions and the quoting and the aliases, what does the final command actually look like right before it gets executed? Wouldn't it be incredible if you could just ask the shell to show you its work?
Well, guess what? You can. The magic command is set-x. This basically flips a switch inside the shell that puts it into a special trace or debug mode. From that moment on, for every single command you run, the shell will first print out the final, fully expanded version of that command. Just look at the power of this. With set-x turned on, you run your command with the $shell variable. But before it shows you the output, the shell prints a new line that starts with a plus sign. And that line shows you the final command it's about to run, with $shell already expanded to its value /bin bash. You can literally see the substitution happen in real time. This is an absolute game changer for debugging scripts. Now, this is important. Once you're done debugging, you have to remember to turn this mode off using set plus x. Yeah, the syntax is a little weird. -x turns it on, and +x turns it off. Just think of x for execution tracing. It's a bit counterintuitive, but you'll get used to it.
Whew. Okay, that was a lot to take in, but you now have the core principles for speaking the shell's native language. Let's pull everything together into one handy reference guide.
And here it is, your personal cheat sheet. We learned how to use quotes to control our text. We learned to use the $sign to access variables. We used type to figure out what our commands are, alias to make our own shortcuts. And of course, the ultimate debugging tool, set-x. These 5 concepts are the real foundation for everything else you're going to do in the shell.
You know, we started this whole journey feeling like the shell was this unforgiving, mysterious black box. But now you have the tools to understand its language, to see what it sees, and to make it do exactly what you want. You can basically read its mind. So the only question left is, what are you going to do with that power? What will you build?